Question A. We can't really put those together using the multiplication rule unless we have the same base number. So if we go over here, 8, I hope you'll know, is 2 times 2 times 2, which we could express as 2 cubed. So instead of the 8 as written in the equation, I can replace that with 2 cubed. So we get 2 to the 15 multiplied by 2 to the power 3, and using a bracket, raised to the power of negative 4. So we get 2 to the 15 multiplied by, now 3 times negative 4 is negative 12. So this is 2 to the power negative 12. Now we can apply the multiplication rule. 15 minus 12 is 3, so this is equal to 2 to the power 3. And if they want it as a single digit, 8. Okay, part B. Now, 128 is one of those GCSE numbers that I ask you to remember. I always start by remembering 2 to the 5th is equal to 32. Well, 2 to the 6th, therefore, is equal to 64. And 2 to the 7th, the number that we want, 128. So again, back over here, I can simply replace the 128 with 2 to the power 7. Now, we've got the same base number on either side of the equation, and they're raised to different powers. It means that the power line must be equal. So we get x is equal to 7, and that's your answer. Part C. The cube root of x. Right, to remove a cube root, we can simply cube it. But if we cube the left-hand side, we have to cube the right-hand side. So let's write it out, but I'm going to use the fractional notation rather than the umbrella cube root as we've got written there. So this is x to the power of a third, which I'm now going to cube, equals 5 cubed. Well, as I've already hinted, x to the power third now multiplied by 3 is simply x. So we get x is equal to 5 cubed is 5 times 5 times 5, which is 125. And that's the answer. Part D. Well, the 4 is not a 2, but we can transform a 4 because it simply equals 2 squared. Okay, writing it in, we get 1 over 2 squared multiplied by, now I'm going to use the fractional notation again, 2 to the half. So the denominator we can apply the multiplication rule to. 2 plus a half. Let's come over here very quickly and just add 2 plus a half. Yes, of course I can express it as a mixed number of 2 and a half, but it's simpler in these situations to transform that to a single fraction. 2 is 4 over 2 plus 1 over 2. So this is 4 over 2 plus 1 over 2, 5 over 2. So putting that together, we've got 1 over 2 to the power 5 over 2. The alternative to that is to introduce a negative power, 2 to the negative 5 over 2. You can take your pick as to which one you prefer as an answer there. Right, part E looks frightening, but it isn't. Okay, I think the first thing to do is to transform those root symbols into fractional powers. We've got, so we're looking at the left-hand side, we've got a multiplied by a to the half, divided by, well, we've got a squared there, but that's raised to the power of a third. That's looking a little bit better. Now, we can apply the multiplication rule to the top. Remember, this is a to the power 1. So 1 plus a half is a to the power 3 over 2. Divided by, now this is not the multiplication rule. We are not adding the powers, we are multiplying them. And this is a to the 2 over 3. A bit of symmetry there. Now this is going to be an application of the division rule. This is equal to a to the 3 over 2 minus 2 over 3. Well, we can put this all on a denominator of 6. 2 into 6 goes 3. 3 times 3 is 9. Minus 3 into 6 goes 2. 2 times 2 is 4. And this answer is 5 over 6. So this is equal to a to the 5 over 6. And that means that k must be equal to 5 over 6. And that's the answer they're looking for. Part F. Now, we've been doing some quite high-level power work, but don't forget the basics. If you look at this equation, we've got a 3 here, and the right-hand side is 3 times 8. So we can get rid of that 3 by dividing the whole equation by 3. Therefore, we've got rid of the 3. This is 4 to the 2k plus 8. And that is equal to 8. So simplifying further, we need to get rid of that 4 and transform that into 2 squared and 8 into 2 cubed. So let's do that. So the 4, 2 squared. Remember, this is now bracketed and all raised to the power of 2k plus 8. And on the right-hand side, we've got 2 to the power 3. Well, we've got the same base, so we're going to be able to equate the power line. Let's multiply that left-hand power line out. Now, the 2 is going to be multiplying the 2k and indeed the 8. So the left-hand side becomes 2 to the power 4k plus 16, and it's equal to 2 to the power 3. So again, therefore, 4k plus 16 is equal to 3. Rearranging the furniture, 4k is equal to 3 minus 16 is negative 13, and therefore k is equal to negative 13 divided by 4. And that's it.